We all suck at beer pong. So we built this. It tracks balls autonomously and moves the cup using a magnetically coupled gantry system underneath.
We wanted our design to be nice and lightweight, which means we needed everything to respond very quickly. In order to do that, we need to have the motors not being lugged around by the gantry. Instead, we're using a core XY design that has the motors stuck in place, while the gantry itself is moved by a system of pulleys. This allows our system to run quite quickly.
Oh! 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 That's the speed it's going to run at.
There's also the table itself, which turned out to be probably one of the hardest things to build. Building a table sucks. I don't know how the IKEA people do it.
It's this one.
We chose to build our own table instead of buying one because we wanted our tabletop to be as thin as possible. We were worried that the magnets weren't going to be strong enough to move the cups if the distance was too large. We built our table out of scrap wood and metal that we found at random maker spaces and our dorm. And we mounted these legs using tough resin.
In hindsight, the magnets were plenty powerful, so we probably could have just bought the table. But at least we've learned a lot about woodworking.
That is a screw. I can do things. Bob the Builder, we can do it.
The mechanical design is only half the battle. We know how to move, but we need to know where to move to. That's where the vision comes in. So it turns out that it's really hard to track a ping pong ball, especially if you got $10 cameras from Amazon. So our first thoughts were to try to detect the color of the ball, or to do some kind of circle detection, but it turns out that the ball just appears as a blur on the camera because it's moving so fast. So instead, we can do a background subtraction to isolate all the things that are moving and then do some math to find all the things that are moving like balls. We put some April tags on the table to do some kind of perspective correction, and then for simplicity assumed that the ball's overhead path was linear.
Okay.
Well, it moved to the right place.
But it moves about 2 seconds too slowly. We need to be able to figure out where the ball is going to land long before the ball actually hits the table. Instead of an overhead view, we then tried a side-mounted approach with parabolic trajectory estimation. It's so much more responsive. It's not perfectly reliable yet, but we're working on it.
There's a lot of improvements that we would like to make over the coming weeks. For example, currently our motor drivers get too hot after about 30 seconds. So we want to think about a cooling system for our table or just replace the motor drivers. Also, we want to improve our tracking and vision system so that we can get stereo vision working on the system so that we can predict the path of the ball more reliably.
This could move any item on here. This allows for infinite applications. Imagine arranging a desk or even helping people that can't have access to things across the table. We see a world where devices like these can be used universally across many different tables and help everyone suck at beer pong.
We all suck at beer pong.